Hi, I'm Paul Epps. We're doing Leetcode must know interview questions. The challenge today is best time to buy and sell stock 2, not to be confused with best time to buy and sell stock, which is the one that we did yesterday. So this one is flagged as a medium. Yesterday was easy. I don't think this is I don't think this is really much more difficult than the one yesterday. Well, I'll get to why they may call it a medium, but let's look at what we need to do. You are given an integer array, prices, where prices at index I is the price of a given stock on the ith day. Okay, same thing. On each day, you can buy and or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it and then immediately sell it on the same day. I don't know why you would do that. It's just a wash, but maybe they meant to say you can sell it and then buy it back on the same day. The problem from yesterday is just you can buy once and you can sell once. On this one, you can buy and sell as much as you want, but you can only hold one share at a time. All right, find and return the maximum profit that you can achieve. All right, so let's look at see if there's any interesting constraints down here. Prices. Okay, the length of the prices array could go as high as 3 times 10 to the 4th. What is that? 4 zeros. So 30,000. 30,000. Now, what might make it medium is, let me think about this. It seemed like the intuitive way to do this. The first thing that kind of jumps out at you is I could just take each price, I could run a loop through each price in the array and then a nested loop for all of the subsequent prices. And by doing that, I could figure out what, if any, is the best way to profit from today's price. That algorithm, because it's a nested loop, is O of n squared. Now, what is 30,000 squared? So you have 8 zeros, so that's 300 million. 300 million operations. That's probably going to time out. So that is probably why they give it a medium, because what seems like the most obvious solution is unlikely to work. All right. But let's look at something that, maybe we can solve this with an O of n algorithm, just one pass through the array. Let's look at example 1 and try kind of a peaks and valleys approach, where we are not going to buy when we're going into a valley, but we'll buy when we're coming out of a valley. So we're going to start, I'll put a tick here for the loop index. We're gonna go one pass through the loop. We're gonna do one pass through the loop. We're gonna compare each element to the previous day's element. And if the previous day's element was lower, then we're going to buy it and sell it on the previous day. I know, you can't do that in real life, but in this, exercise, we can. We can see what the price is today, we see what the price is yesterday, and we can buy it at yesterday's price. So if the price is lower on the previous day, we're going to buy it and sell it. So is 7 lower than 1? No. So we're not going to do anything. Now on this one, 5 is, did I just say is 1? I don't remember what I said, but 1 is less than 7, so we're not going to buy at 7. Um, 5 is greater than 1, so we're going to buy at 1 and sell at 5, and that gives us a profit on that day of 4. All right, next day is 3 greater than 5? No. Next day is 6 greater than 3? It is, so we're going to buy at 3, sell at 6, and that gives us a profit for that day of 3. Last element, 4. Is 4 greater than 6? No, so we don't do anything. Total profit is 7, which is the answer that they want. Okay, now you might say, yeah, but look at example 2. I mean, example 2, obviously the right thing to do is to buy on day 1 and to sell on day 5 and get a profit of 4. Well, yeah, but buy on day 1, sell on day 5. Okay, so you're going to have 3 days in the middle there of paper gains. We're not going to do paper gains. All right, we're going to look at 2 and compare it to 1 and say that's a buy. So we make $1 on day 2, compare 3 to 2, we make $1 on day 3, we make $1 on day 4, we make $1 on day 5. Result is the same. It's 4. So let's look at the code for this. All right, so we need a variable here to keep track of what we're going to call max profit, which is initially 0. We initialize it to 0 because there is an example down here, right, where yeah, example 3. So the stocks are declining all the way, and the ultimate output turns out to be 0. So we initialize max profit to 0, and then go into a for loop. For int I equals 1, I is less than prices dot length I plus plus. If prices, if today's price is greater than yesterday's price, so I minus 1, we are going to buy it and sell it and add that to our profits. So max profit equals, plus equals prices I minus prices I minus 1. Okay. After the for loop, return max profit. Let's try it. Actually, I can't see the test result down here, but something is wrong. Oh, forgot to capitalize it. Max profit. Okay, let's try it again. All right, basic solution accepted. We'll go ahead and submit. No. All right, fast algorithm beats, what is that, 91%? All right, so there is the solution. I think if anything, it's a little bit simpler than yesterday. It's just that, you know, I think if you if you took what seems to be the obvious way to do it with a nested loop, then you get you get an unpleasant surprise when it times out. So that's the solution, and feel free to like, subscribe. See you next time.